Okay, so our goal is to find p with respect to x and p with respect to y. And p is the function of what? P is the function of u, v, and w. So p is a function of three variables. And then each of those variables are a function of x, y, and xy. So if I'm gonna write out this general tree diagram to help me visualize this, I go p, and then I go u, v, w, and then I go xy, 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 xy. And I could write right here the step. We go from p to u by doing what? We go d, du, and we go d, dv, and we go d, dw, and then we go from u to x by going d, dx, d, dy, d, dx, d, dy, and yes, the same, like there's a pattern here. If you think about it, it is exactly the same, right? The exact same thing is going on here. Okay, so now that we got this established, it's going to make what I'm about to do a lot more sense. Okay, so let's start off by taking the partial derivative of p with respect to u, v, and w. Okay, but now let me actually take that back. I'm going to write out what dp dx is and dp dy is in its most general form. So I'm not going to, and I always recommend you do this. Don't just try to jump straight into it because you're going to make a mistake, okay? You're going to make a mistake if you try to do everything at once. So write out the general form and then find those derivatives. So dp dx. Okay, well, what is that? That's going to be dp du dx plus dp dv 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 dx plus dp d what? dw dw dx. Okay, and then what else? Now we have to do dp dy and since I'm using a shitty program called Google Jamboards, I can't just copy it. I can't just copy and paste all of this here. But you could, if you had a good program, you could just copy and paste this all and then change. What do you change? You just change all your x's to y's. So yes, I'm just gonna rewrite everything, and all I'm gonna do is just change all the x's to y's. That's the only thing that is changing. Nothing else is changing. Okay. So this is our most general answer. I mean, this would be, if we didn't have these explicit functions, this would be our answer. But we do need to actually get a finite answer here. Not a finite answer, a finite function, not just a description. Okay, so I'm going to do this in blue, this task. So what I say is we should find dp du. dp du. So that's this with respect to u. Okay, so if you take this derivative with respect to u, the 1/2 will go in front, so it's going to be 1/2. And yes, there's a u squared, v squared, there's w squared here. This is now to the negative 1/2. And now you're only taking this inside derivative with respect to u. So everything else that's not u is going to be a 0, and this inner derivative is just going to be 2u. So your answer, if you want to simplify it and make it look a lot better, which I recommend you do, is u divided by the square root of u squared plus v squared is w squared. Okay, now this is the important part, is that you need to trust me when I say that dp dv and dp dw is, now guess real quick, just if you know what it is, just guess it in the comments. If you don't, just guess it in the comments before I write everything out. And what do you think this is, by the way? Yeah. Square root u squared v squared w squared. Now the reason why I know these without even taking the derivatives, because look at this. This is perfectly like it's a u squared, it's a v squared, it's a w squared, and they're all square rooted. So I mean, it's like it's a symmetrical function with respect to those three variables. Therefore, its derivative with respect to each different variable must really look like this one. And the only difference is it's a instead of a u here, it's a v because it's respect to v. Instead of a v here, it's a w because it's respect to w. Okay, so that's an important conceptual um, trick to understand to speed all of this up. Because if you're on an exam, you need to be able to take these derivatives as fast as possible. Okay, so there's another common thing we need to find. What is that? Okay, now we need to find du dx, dv dx, and dw dx, and yeah. So this is the more individual part. I'll do this in green for all of this. So du dx. So we take u with respect to x. What is that? Okay. It's just going to be e to the y. Okay. Let's take du with respect to y now. Okay. Oh, one second. I did something. Yeah. Okay. Yeah. Let's take u with respect to y. So I'm doing this. I'm taking all these derivatives. So that's like, you could focus on it this way, right? So u with respect to y, what is that? Okay. It's going to be x e to the y. Okay, that's pretty nice. Okay, let's do this set in blue now. So dv dw, nope, not dv dw, dv dx. So this with respect to x, what is that? Oh, okay, just y to the x. Okay, what else? Now we gotta do dv dy. Again, now we're just gonna take this derivative with respect to y. Okay, well, just e to the x. Okay, now let's go to yellow. And we're gonna take, oh, don't wanna see. You wanna take these derivatives. Okay, so dw with respect to x. What is this derivative with respect to x? Okay, so remember, it's going to be whatever is in here, you take that derivative with respect to x and you put it in front. So it would be y e to the xy. And then let me guess, dw dy is going to be x e to the xy. Right? Remember, this problem is made specifically to be as symmetrical as possible, so these derivatives come out as clean and as similar as possible. And look at this, there's e to the y here, and then there's e to x here. There's a y e to the x here, there's x e to the y here. It's like equal opposites, right? That's what I'm kind of hinting at here. I mean, you really see the patterns. They're really trying to show you a story here. Okay, and the reason why I find all these derivatives before I put them in this nice formula is because we've got to evaluate it. Okay, so now I'm going to do this part in black. So if we evaluate this when y is 2, okay, so we get that, let's write it, that du dx is e to the 2, and we get that du dy. If x is 0, okay, thank God it's a 0. We get dv dx. If y is 2 and x is 0, it's just going to be 2. If we get dv dy and e to the x, it's just e to the x, so it's just going to be 1. And if we take dw dx and evaluate it, okay, y is 2, x is 0, so it's just going to be 2. Okay, you can see the pattern already, right? And this, it's just going to be 0. dw dy is equal to 0. So look at this. There's a 0 here. There's a 0 here. And there's an e squared. There's a 2 and a 2 and a 1. 0. Okay. So there's two things are the same, two things are the same, and there's two things are different. Oh, we gotta do one more set of evaluations real quick. So if we plug, okay, we can't actually evaluate these yet because we don't have what U, V, and W are. We don't know what they are. They only give us X equals 0, Y equals 2. So what we need to do is we need to use these values to find what U, V, and W are. So U, V, and W. Okay, so if we put in 0 and 2 into this formula, well, U is just equal to 0. Okay. Now if we put in 0 and 2 into this, what do we get? We just get 2, right? And if we put 0 and 2 into this, we just get 1. Okay. So now we can evaluate these. Okay. So this is just equal to 0. What is this? Okay, so V is 2. It's going to be 2 divided by the square root of, okay, this is 0. This is going to be 4 because it's 2 squared. And this will be 1 squared. So it's going to be 5 in here. Okay, what's W? Well, W is just 1. And it's 5 here. So, again, it's the same thing here, so it should be the same, right? Okay. So now we can write our answer, and we'll do it in green. Okay. So dp dx. Okay, so dp du. Okay, that's 0, and it's 0 times, well, 0 times anything. I'm not going to write. So it's going to be 0 plus this. Okay, dp dv. Where is dp dv? Oh, dp dv is here. So it's 2 square root 5. And what is that multiplied? It's multiplied by v dv dx. dv dx is right here, so times 2. And what else do we have here? Okay, we have dp dw, which is right here. So 1 square root 5. And what is that multiplied by? It's multiplied by this. So dw dx and dwx is right here, which is 2. So we get, okay, let's think about this, right? So this is 4, and that's 2. They're both under square root 5. So we get 6 square root 5. Okay. Now let's do dp dy. Okay, so dp du, well, 0. And okay, so you see there's kind of a pattern here. Let me guess. 2 square root fifths, then supping, plus 1 square root 5 times supping. All right, because look, there's a dp du here, there's a dp dv here, and there's a dp dw here. So that's why I really urge on writing all this stuff out explicitly before, because when you do it explicitly before, you don't have to keep finding those derivatives, the same derivatives over and over again. And you could see that there's a lot of times you'll have zeros, so things will just nicely cancel out. Okay. Well, du dy. Okay. Oh, look at that. There's a 0 here. So look, I really did predict it. Okay. dp dv, like we said, that's this, but it's times dv dy. Where's dv dy? Okay, that's times 1. And this is dp dw, which is over here. dw dy. Okay, so it's a 0. Okay. So our answer is 2 square root 5. So here and here. All of that, right? A lot of work just for 2 finite numbers at the end of it all. But remember, there's a way you can do this faster if you use my method, right? Break it up into parts explicitly so you don't have to keep taking the same derivatives over, and so you don't mess up on any algebra or any calculus, right? You don't want to lose points for, like, and this is chain rule, right? It's a chain of effect. If you mess up somewhere in here, when you're trying to evaluate all this in your head, everything else is going to be wrong. So you need to make sure you get everything first and make sure it's all correct before you move on.